Hey guys, so here's a little update on what I've been doing here. So this is a 12-volt battery. This is the output. That's what's running here. It's running this coil. These coils are just charging coils. This one here goes to that light. These ones aren't hooked up to anything right now. Just this one here is driving. So what I have here is a frequency driver right here, which is making about 350 hertz on average, which fires this field effect MOSFET on and off by IGBT. Here's a reed switch, which gives all the 350 hertz pulses 5 times per revolution. Whenever the reed switch is on, it'll give 350 hertz on and off pulses to the coils from the IGBT. Here's the pulses up here. This might help to explain it a little better. Sorry I don't have you guys on the tripod. But here you can see that now you can see the pulses, like every time you can see the sine wave, a real low sine wave right here. But that's every time it goes up is when the reed switch comes on, so that's when it gives the pulses. And when the reed switch is off, there's no pulses. But you can see there's quite a bit of current in that back spike, as you can see how wide that leg is on the bottom. That shows you how much, it gives you a really good indication that there's a lot of current in your back spike. And the MOSFET's turning on very nice and off. And the back, like the current from the back spike even has a back spike, which kind of definitely doesn't help the rotation of the rotor having that there, but yeah. They're 20-volt divisions. And I've got a trumpet wave there at the end. Well, yeah, it's just this is the frequency driver circuit right here. It's on the breadboard there. I've got it. I use one of these. I just chop off a couple pieces here, chop it in half for that, and use that, solder that in there so it's easy for me to change the capacitor value right here for adjusting the frequency without having to desolder or anything. There's a 12-volt regulator. That's about it. Pretty simple circuit, works awesome. I'm just taking a reading here on one of these cells. What I didn't show you, here's the input watts going in. Kind of fluctuates up and down with the frequency, and here's the output. Sometimes the output is greater than the input. It's a really good ratio in to out. It's a very efficient circuit for driving pulse motors. That's with a 350 hertz pulse and the frequency. And here's the wires. red one going to the output right here. I mean the yellow one. The white one's over here. Comes to the shunt negative. Moves to there. Shunts the positive. We'll do series. No tricks. It's real. These ones here go to the motor. Red one comes around to the positive. Black one's right here. Negative. And then the input's right here. Black wire right there to the shunt of this one. And the positive's right there, goes directly to the battery right there. If I crank it up, see, they're up to about 7 watts or so. If I crank it, it's about 10 watts or so to go into the motor. Seeing those lights are now being powered, and also this cap bank here is being powered. It'll start to charge that cap bank from that set of coils there. But as you can see, as it turns up, the duty cycle's on 100% now. There's no more individual pulsing in between. Like, you know, as the reed switch turns on, it's one continuous pulse on until it turns off again with the reed switch. So it makes it so that there's very little back EMF. Get a tiny little bit. This is how most people have their pulse motors set up. Just so that it turns on once per pulse when the magnet hits, right? You can see here, I'm using about 8 watts, 9 watts or so. Hardly charging at all. So let me just turn it down enough so that it gives that 350 hertz again. And that's about what your maximum out will be. Is with that 350 hertz, you'll get roughly 1.3 watts, no matter what speed the motor is going. If I stop the motor, it would do the same thing. If I turned the frequency drive way down, so it has really small inputs. Right now it's still charging a little bit, but it's still charging there and here also. Just turn this down a bit more. Bad, 1.7 watts out. Using 7 to power the lights and charge. Turn it down a little bit more. About 6 watts. Turn the lights on and getting about 2 back. That's not too bad of a ratio, 3 watts in, 2 out. Close to it on average. It doesn't change all that much. Load the rotor down a little bit. You're still going to get the output, same output. Sorry guys, try to show it both. I have my finger on the rotor. Just took it off again. Yeah, just wanted to show that.